Awesome. Hey everyone, welcome, a few of you around here. Uh, Actually, you might have seen on the agenda our co-founder Marcin, but my name is Filip, and I'm here to replace Marcin as he couldn't make it here today. Also, since I'm not that technical person, the topic is slightly changed. Instead of the multi-dimensional price feeds, I'm supposed to talk about rollup as a service and oracles and what's the intersection between them. So, to kick things off, I would love to introduce you Redstone a little. For those of you that are not familiar with us, we've been around since 2022. Our founder has been around in crypto for much longer, obviously. But 2022, we announced our seed raise with investors like Lemnis Cap, Maven 11, Coinbase on the cap. Then in 2023, we announced another angel round, which was led by a lot of builders. Just to mention a few, Sandeep, Alex Gluchowski, ZK co-founder, or Emin, co-founder of Avalanche, were on our deck. And you might notice that a lot of these people that invested in us actually are building their own ecosystems. That's because they understand the importance of oracles when you build out the new layer 1 or layer 2 chain. Again, last year we launched our research arm and did a couple of very deep dives and very comprehensive reports. We did one on stablecoins, RWAs, yield-bearing products, LSTs, and LRTs. And I believe these deep dives give you a broad, comprehensive view of their particular topic, but also what's the intersection between oracles and the restaking, for example. And our last LRT report around 120K views. We are still quite lean team. Most of us live in Warsaw, Poland. Around 20 people, and 80% of them consist of actual builders and developers in the space. Now, to give you a short intro, I think a good question is, why do you need an oracle for your chain? So basically, oracles deliver data on chain for it to be used in smart contracts. And now, I really like this short comparison of oracles being the internet connection for chains that are that have computing power, but they need the internet plug in order to be able to do the actual computation and use this information further. And now, in theory, oracles can deliver on-chain any kind of data. So it can be weather data, election, prediction markets, sports, whatever. But due to current culture of crypto markets, naturally the most demanded data is the market data, and that's what we actually focus on. And I have a question to our audience. If you guys have any idea what's the most utilized price feed through DeFi right now? Sorry? Yeah, simple as that. If USD is the most utilized feed, that's simply because it's the asset present on pretty much all L1s, L2s. But also a lot of assets are actually denominated in ETH. So if you have LRT price feed or LST price feeds, they are usually denominated in ETH, and that's why the ETH is queried ETH is responsible for 90% of the price feed queries. Now, oracles have wide use cases in crypto, but currently pretty much the whole DeFi, or at least most of the DeFi primitives, are reliant on oracles. And just to name a couple of different types of projects that rely on oracles, Those are usually lending markets like Aave or Venus, CDP stablecoins like, for example, Liquidity or Prisma, leverage protocols, composable leverage, Gearbox or Delta Prime, derivative protocols, Synthetics or GMX, yield protocols, for example, Sommelier, Enzyme, Extra Finance, or algorithmic stables like Minto or Frax Finance. And now the question to you guys, can you come up with 2 DeFi protocol types that doesn't require oracles? Just to whatever protocol that don't need oracles at all. Sorry? Exactly. DEXs are a perfect example. They do have some intersection with oracles though, since DEXs are a data source for most of oracles, especially if you have like on-chain native asset price feed. But yeah, this is like one of the DeFi dApps that doesn't require oracles. Another one I really like is peer-to-peer lending, and I always like to give the Blur Blend example, which is one of the few protocols that have sufficient liquidity while being oracle-less. And actually, if you can build an oracle-less protocol, while maintaining the capital efficiency, then you probably should do that, because it's always like additional attack vector. But so far, if you want to get the capital efficiency, the highest one, it's pretty much impossible not to rely on price feeds. So why oracles matter so much for Rollup as a service? Basically, if you're kickstarting the new ecosystem, you need to have an oracle to have DeFi present on your ecosystem. And now with RAS, it's very simple to spin up new chains. The amount of time needed to create a new blockchain or like whole new layer is like moved from months or years to weeks or days. Now, what we can do as a Rollup as a service creator or as a Rollup creator, you can go to Chainlink and ask them for deployment on your chain, but they will probably tell you to circle back to like talks with them in a couple of months. The deployment will take pretty long time. I mean, don't get me wrong, we truly believe the DeFi space wouldn't be here without Chainlink, and they push forward a lot of great stuff, and we're really thankful to them for this. But for like new ecosystems, new chains, it's pretty much impossible to get them on board in like any reasonable time. And again, question to the audience, if you guys have any idea how many chains does currently Chainlink support? You can just bet, guess. Yeah, that's a close one. Actually, they currently support around 13, from what I, last time I checked. But yeah, that's pretty much the amount. Just to give you a little bit of the comparison, right now, we are probably present on like 40 chains that are like actively growing and actively developing, probably 50 or 60 that are like present out there. And with current RAS, we expect to give a couple new chains integrations every month at least. So now the question is, why cannot Chainlink deploy on all these new chains? The key bottleneck is that on-chain data storage cost is high, and also every new integration requires much more additional monitoring. And the key consideration is that you need to set up strict update conditions for any new feed you deploy on any new chain, so that'd be heartbeat and deviation. And now this is pretty important because if you implement oracles to your ecosystem, there are a few models of data consumption, that being push and pull oracles. And now I will explain to you a little bit more about the differences between these two. So the push Oracle model, this is like the OG or like classic model of data consumption. It was introduced by Channing back in like 2019, 2020, and is like mostly popularized for the whole DeFi. This is basically the model where you set up Relier infrastructure on Oracle end, set based conditions that be heartbeat and deviation. So for example, every 0.5% deviation and 24-hour heartbeat, you update ETH price on-chain and constantly push the price on-chain. And the second model, the pool model, works completely different. So basically, instead of deploying Relier infrastructure and constantly pushing the prices on-chain, the data is stored off-chain and is being pushed into the ETM only when user makes a transaction. So only when data is needed, that's the moment when the gas is being paid and the data is being injected. That allows for like higher refresh rate, but also much more efficient way of consuming data. Now, with push model, what's different is you have gas coverage and whole infrastructure coverage, either on protocol or Oracle's end. That meaning like 24/7 monitoring needed and like additional steps and additional infra like RPCs, for example, needed for this implementation. While in pool model, let's say user deposits into the protocol, it's his transaction that makes the price go on-chain. So he pays a little bit additional of gas, but there is no gas cost recurring on Oracle's end. Now, in terms of cross-chain scalability, if you like build new layer, you naturally want to have at least a couple of feeds available. Like 10 is reasonable, 5 at least is reasonable. So with the push model, for every single new feed, you need to deploy a new piece of infrastructure, which again gives you much more work and more costs. With pool model, you can maintain a lot of assets while not really like deploying a lot of reliers or setting conditions for every single asset. That's because it's automatically pushed on-chain by user transactions. And again, the second, like the next condition, which is the number of feeds, naturally in the push model, it's limited. With pool model, it's much more versatile and much more flexible. So you can have multiple data laying out there and just being injected on-chain when the protocol calls the data. Now to explain you how the standard push model works. Basically, the data is first being aggregated from data sources like data aggregators, CoinGecko, CoinMarketCap, CEXs, like for example, Binance, OKX, KuCoin, DEXs like Uniswap, SushiSwap, where the liquidity is. Then node operators, aka data providers, take out the data and push it into smart contracts on target chains. Then the data is read by dApp smart contract. What's the problem with that model? Again, it's non-scalable across chain. The cost of storing that data is expensive, and you need to pay it even if you don't really need that data at the moment, and the number of assets you have is limited. We like to really do this comparison of the push model to email. So email was the first way of messaging. It's still used around, and like it's still very good for some use cases, but you currently have a lot of different ways of communicating, like Telegram, Instagram, whatever you use. So we believe the push model is here to stay. It will still be around and probably a good fit for some types of dApps. But we believe the pool model will get more and more popular and more market share in due time. Now, what's the data flow with the pool model? Basically, the first step is quite similar, where you have the data sources and data provider nodes taking out the data. But then, the data is being injected into the middle layer. It's essentially like, in our example, a stream of nodes, off-chain stream of nodes. Every single data provider that is allowing for on-demand data has this middle layer. For example, for PIF, it's PIFnet, which is Solana fork, but they like own the whole supply of the tokens, so it's like very cheap for them to push the prices to their middle layer. And then the data is being pushed from the middle layer into the target chain through different ways. So, for example, PIF uses Wormhole for it, which is a bridge for cross-chain messaging. Another way of injecting data from the off-chain component is through Liquidator pushing the price on-chain. So let's say user gets liquidated, and Liquidator who liquidates his position, for example, on Aave, is pushing the data with his liquidation transaction. Or the way we actually implemented it is to piggyback user transaction and inject the data in the call data of user transaction. So basically, when user interacts with the protocol in any way, he pays a little bit more in gas, and it's his transaction that is pushing the data from the middle layer into the target L1s or L2s. And you can like go to our showroom.redstone.finance, where you can find like 40 different chain integration and just query the data out there yourself, check out how it works. So now, like, what's the main, I would say, conditions based on which you should pick your Oracle provider for your new rollup? So the main conditions are waiting time. So how long does it take for the Oracle to deploy on your new chain? And now, again, with push model, it's much longer time. With pull model, it's usually much faster. What's the cost? Again, push model requires much more monitoring and infrastructure to be present on chain. Pull model is faster and cheaper, but you also should be aware of the types of application that you want to bring to your ecosystem. That's because, like, being transparent, at least for now, most of the dApps are used to consuming data in the push model. So usually when you build out new ecosystem, there are always a lot of new forks coming in. For example, Aave forks, Compound forks, whatsoever. Or a lot of, like, if you like well-established, you want to onboard blue chip projects, they also consume chaining on other chains. And if they want to come to your chain, they usually like to consume data the same push model way, which basically means they don't want to adjust their code in order to be compatible with the pull model. So when you pick which type of the Oracle you're looking for, you really should first look into how the ecosystem landscape look like and what you're looking to have into your ecosystem. Now to give you some case studies, Manta Pacific, this is one of the RAS user. It's basically a chain that was built on top of Caldera, and first it used OP stack. Currently it's built on the ZK EVM stack. It got like very fast, almost 1 billion TVL. Currently it fell down a little, but we're securing most of the assets out there. Another example is Lisk. For OGs around here might be aware of the Dinosaur coin that is currently might be getting another life thanks to building a new L2. And they are going to do it with Gelato and OP stack. And this, like, there is a trend of chains going into some tech stack and like moving to EVM L2s. That's because, at least from what we've seen so far, except for Solana, for example, non-EVM chains don't really get much users and like tons of liquidity. So we are expecting this trend to accelerate of a lot of old L1s moving into L2s using the actual tech stack of the other provider. So now, I'm going to slowly wrap it up, and we'll have to like touch upon main Oracle parameters to keep in mind when you pick the Oracle provider. So basically, customizability is one of them. If you can decide which data providers you want to utilize for the particular assets. Redundancy, so what are the potential fail points for the Oracle to go down? How does the compatibility looks like? So if the Oracle is like fully cross-chain, fully EVM compatible, for us, for example, with EVMs, it's pretty much out-of-the-box compatibility, at least for most of them. Number and types of data feeds available. So how easy it is to add new asset, but also how easy it is to maintain the price feed. This is another important factor. If you have the on-chain and off-chain price sources, so basically there are a lot of yield-bearing tokens right now that are very on-chain native, and you have to have proper tools to aggregate the on-chain liquidity and on-chain data solutions in order to roll out the feeds for them. Another important factors are aggregation methodology. So if it's robust against, for example, wash trading, so if it's volume-based or liquidity-based, you have proper slippage checks in place. What were the historical mispricing manipulations? If you get any guarantee, any kind of collateral that you can get if there is some damage within the Oracle pricing, how much you need to pay for the Oracle integration and for the maintenance, and fundamentals like how does the governance, tokenomics, all this looks like, and probably like 100 other different aspects when choosing the Oracle. Now, slowly wrapping it up, I wanted to show you guys ETH Warsaw a little. That's because a lot of our team members currently live in Warsaw, and we're also involved in preparing the conference. So I think it's a very good time to come to Warsaw, and like if you need a good excuse to visit Poland, next September might be a good one. And yeah, that's pretty much it on my end. If you guys have any questions, feel free to ask me. I'll be around pretty much for the whole day. And thank you so much for coming.